Hello, today we'll be reviewing different sampling techniques and detectors compatible with chromatography instruments by Adan Jose Esquivel Jr. Quadruple mass analyzer. Quadruple mass analyzer separates concentrations by mass to charge m over z as the ions enter one side of a set of four parallel rods. The ions then pass through the center, and when exiting they are identified by a detector as seen on the figure. Using different voltage currents like fixed direct current DC, alternating current AC, and radio frequency RF to filter ions by a specific mass and charge ratio m over z. Quadruple mass analyzer continuation. Quadruple mass analyzer QMA coupled with high performance liquid chromatography HPLC. QMA is a best coupled with HPLC, providing rapid separation of mass to charge ratio m over z, generating convoluting peaks and setting new standards of being user friendly and its durability. Quadruple mass analyzer is widely used for uptime in analyzing and the versatility in approaching a variety of forensic samples that are often degraded or contaminated, as well as having the capability of confirming a specific compound by their specific mass fragments that are obtained with the use of collision-induced dissociation (CID). Time of flight mass analyzer. Time of flight mass analyzer TOF separates ions based on the distance over time it takes for the solution to travel downward to the flight tube. A major difference of TOF mass analyzer when compared to others is spectral continuity, that is, the continuous optimal performance of distribution of ions generated from a source to detector. Time of flight mass analyzer continuation. Time of flight analyzer TOF coupled with liquid topography LC. TOF is coupled commonly with LC, a highly selective technique known for rapid screenings and providing accurate compositions of elements by identifying parent and fragmented ions of unknown compounds. Forensic scientists use TOF coupled with LC for qualitative and quantitative analysis of forensic samples with concentrations of higher molecular mass. Electron capture detector. Electron capture detector ECD generates an electron current from a source within itself and measures a gas sample as it passes through the detector, identifying concentrations with high affinity to electrons causing a decrease in electron current, then measuring the difference of the electron current and the gas sample generating an elite peak. ECD is a concentration detector and is non-destructive of the gas sample after analyzation. Electron capture detector continuation. Electron capture detector coupled with the gas chromatography ECD is the best coupled with GC is a highly selective instrument when conducting routine analysis and a useful analytical tool for volatile and semi-volatile organic compounds. Types of sample techniques utilized are whole air injection onto the packed columns and cryo pre-concentration and thermal injection onto the capillary columns. ECD is mainly used for forensic samples like high electrophilic compounds like halogens, nitrogens, and phosphorus. The levels of measurement are parts per trillion or parts per billion and are unable to detect hydrocarbons. Flame photometric detector. Flame photometric detector is selective due to its using specific radiation sulfur 394 and phosphorus 526 that is released to isolate and identify the gas sample. It does this by igniting the analate with a flame and analyzing the luminescence of the light release of the analate to be identified by the detector. Utilized as a mass detector and is destructive towards the sample but does not get affected by the carrier gas flow due to it being independent. Flame photometric detector continuation. Flame photometric detector FPD coupled with gas chromatography GC. FPD is coupled commonly with GC to analyze in high resolution with the addition of a second identifying parameter and greater chance of reproducibility with organic residues. Sample preparation technique commonly used for FPDGC is multi-component separation analysis of complex concentrations, having two separate columns simultaneously conducting different independent stationary phases. FPD is used to analyze forensic samples that contain organic compounds like phosphorus, boron, tin, arsenic, and sulfur. The levels of measurement are parts per trillion and parts per billion level and used for elemental analysis. Here are my references. Thank you for watching the video.